I'm Sharon Aarons. I'm a senior research scientist here at Agriculture Victoria at the Ellinbank Smart Farm. I lead the soil sciences group here. Our involvement in the Pilot to Paddock project has covered a number of activities. The first activity had an aim around improving nutrient recovery through use of various chemical coagulants and flocculants. So the approach we took was to identify 6 coagulants and flocculants and then systematically test them with diluted manure and provide a clear, usable liquid fraction that farmers can use for other purposes on dairy farms. We're able to show over 95% reduction in turbidity of liquids, being able to reuse that liquid to either rewash dairy sheds or for other purposes. And we also saw, for some nutrients, over a 95% recovery or increase in that nutrient in the solid fraction. In the second activity, we tested a variety of covers for their ability to reduce loss of ammonia from manures, to make that manure a more sustainable source of nutrients for farmers to use and as a replacement for inorganic or synthetic fertilizer. Some earlier work had shown that when you cover manure, it's incredibly effective in stopping ammonia emissions. It stops emissions immediately, instantaneously. So we basically compared 3 types of plastic with controls, and we had them set up in this system behind us. We compared for the first time compostable plastic to reduce the use of plastic on dairy farms, and compared that with untreated, uncovered manures. And preliminary results are showing us that we've got a significant reduction in loss of ammonia. This is going to be of value to the dairy industry because manures that have been scraped and stored will have higher nitrogen value before they're land applied just by using a compostable plastic, and this material will degrade to carbon dioxide and water. No plastic waste on dairy farms. So the third activity was really around developing fertilizer products. We have plots located near to the lab here at Ellinbank, and to those plots we applied effluent that had not been treated and also the sludge that was derived when we applied coagulants. There were 2 coagulants that we decided to test, one called polyferrous sulfate. The other coagulant that we have most recently looked at is derived from the bark of acacia. To date, the results suggest that they have had no difference in terms of pasture response to applying effluent. But the good thing about that, this is from a biomass perspective, we're still awaiting the chemical analysis results, but what that basically tells us is that this material is not detrimental or does not appear to be detrimental from a pasture production point of view, and that is a good message from this result.